Chapter 4.3 is going to introduce another rule on top of the other differentiation shortcuts that we have. So this will bring us up to 5 shortcuts. The product rule is what we're going to learn about in this, and basically what we need to do when we walk away from this video is be able to derive multiplication of functions. So if you ever see products or multiplication, you're going to think of the product rule. And then also understand what the heck a higher order derivative is. So what I want you to do is first consider this function right here. So if you had f of x equals x times x minus 1, what we might be prone to do is this right here. Derive x and then multiply that by the derivative of this other function being multiplied. So this would get us equals, the derivative of x is just the power rule, right? So we're going to bring down that 1, and then it would be x to the 0 when we subtracted 1 from the exponent. So that's just going to get us 1 times, and then this we could derive x minus 1 separately by the sum and difference rule. So this thing is going to be 1 times the derivative of x again is just 1 minus 0. So what we're getting here is that the derivative is just always 1. The slope of the tangent lines of this function is always 1. If you took a look at that, this graph is going to look something like this, like that. There's our parabola because it is a quadratic, and you can see that that's not the case. It's not always 1. So let's go ahead over here and rewrite this. F of x is equal to x squared minus x if I go ahead and distribute that out. So now if we use our proper rules that we've established, so f prime of x, now that I've rewritten, I can go ahead and use the sum and difference rule that I know I have. Okay, and then I can go ahead and say 2x to the first minus and then 1. So this is saying f prime of x is equal to 2x minus 1. So this is the equation that will get me the slope at any given point along this line. And you can see that that would be more fitting. Just test it. So if you look over here, what we did was we tried to make up our own rule. Over here, we rewrote and actually used the rules available. This one down here, you don't really know a whole lot to do with it, so again, what you could do is rewrite. This is x to the 1/2. I'm not deriving here, I'm just rewriting it to get to a point where I can use my rules. And then this I could distribute, this I can distribute in, plus x to the 1/2. And so now I can look at this as g of x equals x to the, and then if I put this over a common denominator, 5/4, because I can just add my exponents, plus x to the 1/2. Now I could go ahead and derive this if I wanted to. So how do we get to this point without rewriting? That's where the product rule comes in. So if you ever have the multiplication of two things and you want to derive it, what we're going to have to use is this right here. And take a moment to try to interpret what that notation is saying. Pause the video if you want, but this is what we've got to do. Another way that you might like is this. Overall, what that is saying, if we're ever multiplying functions, you're going to take the first function being multiplied times the derivative of the second, so the first function left alone, times, and you're going to derive the second and multiply those together, plus the second times the derivative of the first. So leave the second function alone and then multiply it by the derivative of the first. That's what these are saying. Okay, just two separate notations, and that's what we're going to have to follow. New rule, rule number 5. Alright, so let's look at this one again. In the first slide, what we determined was that the derivative of this thing is equal to 2x minus 1. So now what I'm going to do is I'm going to show you we can get there without rewriting. So I'm going to use this rule above, and I'm going to say leave the first function alone, so that's just x, times the derivative of x minus 1, plus, and then now I'm going to leave that second function being multiplied alone, times the derivative of our first. Okay, and when we do this, I'm actually going to now use the sum and difference rule and just individually, conveniently separate those ones because I can. X minus 1 times the derivative of x. So now what I want you to notice is I haven't derived at all yet. I haven't done anything except for kind of just use some rules and set up the notation that I'm about to do. So now I'm going to derive. So x times, and then the derivative of x is just again going to be 1, minus, and then we have a constant rule, right? So there was a power rule, there was a constant rule, plus x minus 1 times, and then the derivative of x, again, power rule, bring down that 1, decrease the exponent, we're going to get 1. Okay, so now, sorry, I have to go up here. So we have x times 1 plus, and then x minus 1. So again, this is just plus a grouping. We don't have to really necessarily have these groupings. So we have x plus x minus 1 equals 2x minus 1. Our product rule just arrived at the very thing that we rewrote for. Okay, same thing down here. We could go ahead and rewrite this one, or not rewrite it, use the product rule. So again, I'm going to leave my first thing being multiplied alone. And then I'm going to say I'm going to derive this thing right here. I didn't have to rewrite a radical because we know that that's just going to be fitting into the power rule. Now I'm going to leave this alone. Okay, and then I'm going to derive, dx, I'm going to derive x squared plus 1. So again, now I'm going to use I used the product rule. There was a product rule. Okay, and now I'm going to have x squared plus 1 times, and then actually, well, yeah, I'll go ahead and derive this. This is just going to be the power rule, so it's going to be 1/2 x to the negative 1/2, plus this one's going to be left alone, and I'm going to do this in one fell swoop here. I'm going to use the sum and difference rule at the same time as using the power rule. So now we're going to simplify this, and it's going to be a little bit strange, but I'm actually not going to distribute everything in, and you'll see why in a second. So I'm just going to bring this out to the front, and then I'm going to have x to the 1/2 times 2x, and I'm not even going to simplify that. And the more we do, the more you'll get in the practice of when do I distribute, when do I not. But now here's the thing. So technique for simplifying. If there is a common factor in each term, pull it out and bring it to the front. It's the same thing as if I had 3x minus 9, for example. What you would observe is say, hey, I have a common factor of 3 in each one of those terms in this family. So what you could do is just pull that 3 out. And technically what you are doing is you're saying, well, I'm going to divide everything by 3, right? Or in other words, I'm going to multiply everything because, again, you could take this family. Instead of doing division, you would multiply it by the reciprocal of the bottom. So we have this thing going on. But now you've just changed the problem, so what we're going to say is multiply a 3 out front. So if you divide everything by 3, then you're going to multiply everything by 3. So what you're going to get is 3, and then 3x divided by 3 is just x, minus 9 divided by 3 is going to be that 3. Okay, so we're going to do the same exact thing down here. For any kind of exponents that are fractions, we're actually going to try to get rid of them, and you'll see your book does this often. We also try to get rid of fractions in general. So this whole thing, I'm going to note that fraction, and I'm going to divide everything by 2x, and the value with the smallest exponent is that negative 1/2, x to the negative 1/2. So technically what I'm going to do is I'm going to divide all of this by, here's x to the negative 1/2, and I'm going to divide this by 1/2 as well over here. So the reason why I kind of ordered, again, this is just multiplication, so it doesn't matter the order. I'm dividing everything so that I can multiply by 1/2 x to the negative 1/2. Okay, so here's what's going to happen in here. This is going to cancel out. So is this. Okay? Here's one quick thing to note. If I had x to the 4th over x to the 2nd, one thing that we could do is say, well, this is just going to be the subtraction of our exponent. So it's going to be x to the 2nd. Same thing here. This thing right here would be x to the 1/2 and then minus negative 1/2. So what just happened is I'm actually going to end up adding those. So x to the 1st. So I've kind of made a mess of this. So we have x to the negative 1/2. And then now what's left here is the x squared plus 1. Okay, and then plus these things right here are just going to become x to the 1st. And then 2 divided by 1/2 is the same thing as 2 times 2, right? So times 4, and then we have this extra x out here. Alright, so we have 1. Oh, fly. Oh, stupid fly. Okay, so we have x to the now we're going to put that on the bottom, alright? And all of this stuff is going to be on the top. So we have 1 times, and we don't really even need that, x squared plus 1 plus 4x to the second. Okay, because I would just multiply those. And let's see what we've got on the top. We have 5x to the second plus 1 all over 2, oh my gosh, 2x to the 1/2. This is oftentimes what the back of the book will notate your answer to be. They pull out any fractions. They also pull out the smallest termed, the smallest exponent term. Stupid fly. Alright, so here are your problems. Using the product rule, you're going to be doing these. And just a quick another example, this is one of your problem 1, use the product rule to differentiate. So again, differentiate just is the process, use the process to find the derivative. So here I go. I'm going to say the derivative of this function, notated with that prime symbol, and I'm going to go ahead and say leave the first function alone, times the derivative of the second, Are you looking for paper clips?
No, I was looking for a stapler.
Oh, right there too.
Too.
Stapler and paper clips are right there. No problem. Oh no, it's okay. It's fine. I can cut all this out. And this stupid fly! Okay, so the first times the derivative of the second, and then I'm going to leave the second alone, times the derivative of the first. So now note, I haven't derived anything at all. I've just set myself up for it. So now, to be very full and complete about this, what I'm going to say then is I'm going to derive each one of these terms piece by piece, and that I can do given our sum and difference rule. So, and then the derivative, I am going to pull out that 2 and do the derivative of just x, and that was the scalar rule, right? So I took these each and I derived them, and I'm going to pull out that 2. Actually, I haven't derived them yet. I'm just setting myself up for it. And then I'm going to do the sum and difference rule here. So the derivative of x squared plus the derivative of 1. Alright, so now I'm going to start deriving using my good old power rule. So we have x squared plus 1. This thing right here is going to be 2x to the first because I saw that and I thought power rule, minus 2 times, and this thing right here is going to also be power rule. Remember, drop down that 1, but then this is going to become 0 when you subtract 1 from that exponent. So it's just going to be 1 because x to the 0 is 1. So that's that piece right there, right here, right there. Alright, plus, and then we have x squared minus 2x. And then here I go deriving this piece by piece. It's going to be 2x to the first, which I don't have to write, and then plus 0. And now let's simplify all this. So we have x squared plus 1. And then here we have just 2x minus 2. Plus we have x squared minus 2x. And then times 2x. Okay, so this would be a moment where you could go ahead and distribute, but I'm going to say, I'm going to call this good, right here. And so most of it is, if the book did have just term by term, then you would have known that they FOILed these out, and then they would have combined like terms. But we're going to leave this to rest right here. Half the battle sometimes is just figuring out that you got the right answer and the book notated it differently. So, we're going to leave it at that. I'm going to say cross out these problems right here. We'll go into higher degree derivatives in the next video.